Hi, I'm Luca Congedo and you're watching from QGIS Remote Sensing. In this tutorial we're going to perform a particular technique of machine learning, that is the random forest algorithm provided by the Snap software, that should be of course installed and integrated in the semi-automatic classification plugin. Please remember to always update the plugin to the latest version. So let's zoom in. So here we have the SCP menu. We can go to the band processing random forest tool. This is the interface of the random forest classification. And also it requires the SSnap software. So before using this tool, check that you have set here in the external programs the path to the SSnap GPT executable that is required for the program to run. So the first thing is to create the band set. Here, band set. So with this button here, we select the input image, in this case a sample of a Sentinel-2 image. Here we select all the bands, we click open, and automatically all the bands are added to the first band set here, the 10 bands. We can use this button to automatically sort the bands by name. We can also select Sentinel-2 in this menu, setting the center wavelength for each band. Now that we have created a band set, we can create a color composite, RGB color composite here. For instance, 732. Here we have the near infrared band, so it's very useful for photo interpretation. Now we can create a training input file here with this button. We enter the name, for instance, the training. And we have here the training input file. So now we are ready to create the ROI polygons. So we use this button here to create ROI polygons, which will define the classes for classification. For instance, here, the first polygon for the water class. Here we set the macro class name, water. The class name, for instance, lake. And we click Save to save the ROI polygon to the training input file. Here we have saved, as you can see, the first polygon. Now we go on and create other polygons for the other classes. For instance, here we can see this urban area. We can create another polygon here with this tool, create ROI polygon. Be sure to use only ROI polygons and not using the region drawing because of compatibility with the Snap software. So here we create another polygon. Here we change the macro class name, for instance, built up. Change also the class name, for instance, built up 1. And of course, we change also the macro class ID. You can click here this button Save again and save this other ROI to the training input file. As you can see, we have the second ROI saved in the training input file. And we go on another region of interest for the vegetation class here. Yeah, we create a polygon. Of course, we change here the macro class ID, the macro class name, for instance, vegetation, and the class name. And again, we click Save and save this polygon to the training input. As you can see, the software is calculating the spectral signature. Now we go on and create another training input for the soil class, for instance here. Here we set the macro class ID for soil and the macro class name, for instance, bare soil, and the class name. And again we click Save. So of course we can create as many Roy polygons as we like. You can see here the whole image. We have several classes. As you can see, for instance, here, this area is a forest area. We can create another training input here. So another polygon, and we save it in the training input as vegetation. We change the class name. And we click Save again. So we have another Roy polygon for the macro class vegetation. So now we can change the color of macro classes, which will be the color used in the classification output here. Here. Bare soil. Here, for instance, yellow. So of course we can create other polygons. For instance, here another polygon of bare soil. We should analyze the classification result and add or remove a region of interest. Of course, we should create other polygons, and we can use the RGB color composite tool here to visualize the image, the color composite, and use this button to stretch the images. So after the creation of several Roy polygons here, as you can see in the whole image, we can perform the random forest classification in the SCP menu, Band Processing Random Forest here. In this tool, we can select the input band set. Here we have the first band set 1, already defined. We can choose between macro class ID and class ID for classification, and we use the macro class ID. We can set here the number of training samples, that is the number of pixels selected randomly by software as training sample. We can also set the number of trees. Usually the more is the better, but also it increases the time required for classification. So usually 100 or 500 is a good number. We can also check here Evaluate Classifier, which will open here in the Output tab the evaluation of the classification performed by the algorithm. We could check these options, Save Classifier, to save the classifier for later use, for instance for classifying other images using the same random forest model, but in this case we are not using this option. So now we can click Run. We set the output file, for instance classification random forest. We click Save, and as you can see the classification started. Of course it requires the ESASnap software, and after a while the classification is performed. As you can see here, classification loaded using the macro class colors. Also a classification random forest conf, which is the confidence raster, is loaded. We can also use these random forest confidence rasters to assess the classification. The higher the value, the more confident is the classification. So if the pixel of the confidence raster is low, we should probably create another Roy in this area. Here, water, built-up vegetation, and bare soil. We can compare the classification to the color composite. And we should also use the output of the evaluation of the algorithm here, as you can see. We have here the accuracy, the true positive and true negatives. So of course this is not the real accuracy of the classification, but it is useful for assessing the accuracy of the model in predicting the classes, comparing the result of the classification to the training input used for validation. Also, we have here the importance of each feature, which are the bands of the band set here. Here you can see a rank. This is useful for assessing the importance of each band in the random forest classification. Of course, these values depend on the training input, so probably creating different rows would change these values. But this is useful for assessing the importance, maybe removing the least important bands for reducing the time of classification. So for instance, here we can see the band 10, which is the 10th band of the band set here. So it's actually band 12 of Sentinel-2. We can see this is the first band in the rank, so it's very important for the random forest algorithm in this case. Of course, this can change with the model and with the training input. So we have performed a random forest classification of Sentinel-2 image. In other tutorials, we'll see how to assess the accuracy of a land cover classification. For any comments or questions, please join the Facebook group of the Semi-Automatic Classification plugin. Thank you for watching.